Hello and welcome back to NUMECA's Lifehack series. Today we will focus on the ZR effect, a special kind of ZR effect, which you may use if you cannot establish a matching connection. This works with a single block which is not modified by the user at all and leads to an extrusion of the main channel into the ZR effect. For that we prepared a case, the rotor of the Aachen turbine, and we have a rising complexity of 3 different ZR effects, which we will show you in the following. So, the mesh of the main channel is already generated, and a geometry, basically a single line, is inserted in the project as well. And then we can basically add a ZR effect, edit that one, define the domain, which is basically that polyline, and then we insert a new block manually. And since we have the kink here, we insert 2 additional vertices, one on the upper side and one on the lower side. Then we move the other ones into the corners and check for unmapped edges. As it's shown, 0 unmapped edges detected, so we can close the edit mode, select all, and generate the 3D mesh, the complete one. Now the mesh is generated, and you can see here already that basically the mesh in the ZR effect is an extrusion of the top of the channel mesh. Now we have another case where the ZR effect is upstream of the blade and also ending upstream of the blade. The main channel mesh is basically the same, and the important thing is that the ZR effect may end inside of a cell and not on the points or corners of a single cell. And that's why we need to enter a set constant line here in that place. And then we do the same steps as before. We add in the ZR effect, edit that one, define the domain, and enter a block manually. Unmapped edges 4, so we need to re-snap the vertices. And it may happen that this edge down here doesn't snap to the main channel side. And then we can basically enter another vertex manually. This is looking better. Unmapped edges 0, and we can close the edit mode and generate again the 3D mesh of the complete domain. Now the mesh is generated, and you can see that the ZR effect is again connected to the main channel with the matching connection. Now the third case is already prepared as well, and here we have the ZR effect starting at the inlet but ending inside of the blade, or let's say on the same axial position. And again we have here the issue that the end here could be inside of a cell, so we need a Z constant line as well, which crosses the blade in that case, and thus we define the streamwise index, let's say in that case for index 31, and let's generate a blade-to-blade mesh first. And the blade-to-blade mesh down clearly shows that we have a Z constant line crossing the blade. Now the procedure is the same as before. Basically, we add in the ZR effect, edit that one, define the domain, insert a block manually, snap the vertices, and again you see that already that this edge snaps to the upper side, so we insert an additional vertex again, snap the vertices, unmap edges are 0, and we can close the edit mode. Again we select all, generate the 3D mesh, and have a matching connection of the ZR effect to the main channel, which even crosses the blade, which is probably the most complicated case you can imagine for that. So that was it basically. I hope I could show you how to mesh a ZR effect with a matching connection and a single block to the main channel. Just let us know if you need further help, and otherwise just see you next time. Thank you.